team matrix, and we'll be discussing about the time series analysis of Australian energy productivity. Data description. The data used for the project comes from the official Australian Energy Update for 2020, showcasing the productivity index variation from 1978 to 2018. The descriptive statistics of the dataset showed that the minimum index is 100 and maximum is 170 with a mean of 127 and 0 missing values. Visual analysis. Figure 2 shows the time series plot of the energy productivity. It shows an upward trend in time with no apparent seasonality or a change in variance. The behavior of the series shows an autoregressive behavior with no solid change point. Figure number 3 shows the scatter plot of previous year productivity index versus current year. It has a clear positive correlation, and this is confirmed by the correlation coefficient of 0.99. Model specification. The ACF plot, which is figure number 4, shows a downward trend pattern which is not ideal. PACF on figure 5 shows a significant first lag. After trying transformations such as box-cox and logarithmic that ended up in no improvement in the series and failing the augmented Dickery-Fuller test for stationarity, we tried first differencing on the series. An improvement was observed, however the series did not achieve stationarity. Therefore, second differencing was done, and this helped in achieving stationarity with a p-value less than 0.05 significance in the ADF test. Parameter estimation. The second difference series was used to come up with ACF, PACF plots, EACF metrics, and BIC table. ACF showed significant lags at 1 and 2, while PACF showed a lag at 1. So possible ARIMA models from ACF and PCF are ARIMA 121 and ARIMA 122. From EACF metrics, ARIMA models 122 and 222 were taken. BIC tables shading showed possible ARIMA models as ARIMA 321 and ARIMA 322. For all those ARIMA models, parameter estimation was done using conditional sum of squares method and maximum likelihood method. Table 1 shows the models and the significant parameters using CSS and ML. From the table, we can see that ARIMA 322 seems like a promising model considering the significance of parameters. However, lowest AIC and BIC both were given by ARIMA 121, so it will also be considered. Residual analysis. Residual analysis shown here are for the two models chosen previously, which are ARIMA 121 and ARIMA 322. The results of the residual analysis for both models are very similar. Both models show white noise characteristics from ACF and PACF plot, and no important information is therefore in the residual component of the series. The QQ plots are fairly normal considering most points follow the straight line. The time series plot also shows no trend as well. The long box text also shows promising results for both the models. Forecasting and conclusion. After analyzing criteria such as ACF, PACF, BIC and EACF, 5 models were obtained. Parameter estimation was done for all 5 models using CSS and ML, and from that ARIMA 322 was selected. ARIMA 121 seemed like a promising model as the lowest AIC and BIC were both obtained from that model. The residual analysis for both models looked very similar, and hence using the principle of parsimony, the simplest model, which is ARIMA 121, was used for forecasting the next 10 years of Australian energy productivity from 2019 to 2028. We can see from figure 14 that the forecast follows a similar pattern to the original time series, and therefore a RMA 121 model might be useful for predicting Australian energy productivity in the years to come. Thank you.